Hello, everyone. Welcome back. This is Miss Byrd. Welcome back to our page. Thanks for visiting. So today we're going to talk about an Algebra 1 lesson called Transformations of Quadratic Functions. Quadratic means that you have a function, usually with the square here around the x, which means you're going to end up with a parabola. And a parabola is the U-shape graph. So here is the vertex form of a function, and we're going to go over each part of this so that you can have an idea of what to expect when you see the numbers in the different spots. So f of x, remember that's a function, equals, now a right here, this number is going to represent how the graph looks. Does it get wider or does it get narrower? So if a right here is greater than 1, and when I say a, I mean actually the absolute value of a. So when you have the absolute value of a, let's see here, the absolute value of a, if it is greater than 1, then your graph gets narrow. And when I say narrow, I mean it's going to look skinnier than from the parent function. Let's say the absolute value of a is between 0 and 1, which means it could be a fraction. So it's going to be between 0 and 1. Then that means that your graph widens. And that means that it's going to look wider than your parent function. If a ends up having a negative here in front, okay, so you have negative a, then your graph is a reflection on the x-axis, which means it's going to be facing downwards, okay? If your parabola is a positive right here, that means these will be facing upwards like this, okay? Let's take a look at H and K. So H and K is actually your vertex. Your vertex, you can tell right away what your vertex will be because you just look at the letter H. So your vertex will be H and K. So let's say it says x minus 2, then here you would plug in a 2. If it says right here plus 3, then K would be a positive 3. Okay, so H tells you this is a horizontal change. That means it's going to shift to the left or right. So your parabola from the parent function would go to the left or go to the right. If you have a number for K, that is a vertical shift, which means your parabola is either going to move up or down the y-axis, or just from the parent function. Okay, so let's take a look at some examples of how that would look. Oh, one more thing before we get started. Usually, these are just some keys. I think I'll get back to that when I show you some examples. Okay, number 1, g of x. Find g of x, where g of x is transformation 4 units up. Now, because we're going up, that means k is the vertical shift. So right here, you would have plus 4 because it went up. So right here, you would plug in a plus 4, okay? Now, because there's no other change here, this would be representing the horizontal shift. Because it doesn't tell us anything about a horizontal shift, then you would leave it as x squared. So your answer, when you're writing your g of x function, would be x squared plus 4. Okay, let's move on to number 2. Number 2 says find g of x, where g of x is the translation 4 units to the right. So now we're moving to the right. Okay, so because we're moving to the right, that means you have a change, a horizontal change here. So you're going to leave it as x minus, but because we're moving to the right, that's a positive 4. So you're going to plug in a 4 here. So all of this would be to the second power. And does it tell us it's going up or down for k? No. So it's plus 0, but really you don't need to put plus 0. So this would be our final answer. So right here, we're going to select, and there's our final answer. Okay, g of x equals, open parentheses, x minus 4 to the second power. Number 3 says find g of x, where g of x is a reflection across the x-axis. Okay, so then that means, just like at the top when we talked about a reflection, that means your a right here has to be a negative. So when we go back to the equation, if it's a reflection on the x-axis, then we're going to keep, we're going to keep x squared. It doesn't move to the left, it doesn't move to the right, it doesn't move up or down, so we're going to keep it like this. But because it's a reflection, that means it's going to look downwards, which means you have a negative in front of x squared. So our final answer, the equation should be negative x squared. Number 4, okay, so now let's look at it this way, where you have the picture of the graph. The graph shows g of x, which is a translation of f of x equals x squared. So the parent function is x squared. Write the function rule for g of x. Okay, so what happened? Your parent function is always, your vertex is here for the parent function, and you end up here and here for the parent function, and also at 2 and 4, 2 and 4. So this is, if you were to graph your parent function, it would look something very similar to this. This would be f of x, okay? So you can see that there was a change and it moved from the parent function to the left, okay? So because it moved to the left, if we go back over here, this is a horizontal change and it moved to the left, so it's actually a negative number. And then you want to check how many spaces did it actually move. So if it moved one space, it's -1, correct? Because it moved to the left. But your original function said x minus h. This is h, right? So when you have a negative like this, it's actually +1. And if you take a look at this little shortcut, it tells you when x plus h, that's actually a movement to the left, okay? So when we go back to our problem, because it moved to the left, we have x, and it moved one spot from the vertex here. It moved one spot to this vertex. It moved to the left one space, and then it's to the second power. Now, usually you would have plus k if the blue parabola went up or down, but it did not move, so you do not need plus k here. So our function is x plus 1 to the second power. And then here is an example of that graphed. So you'll see that in pink, it's the parent function x squared, and then g of x, your new function, is moving to the left. Number 5. Here it's asking us, if given f of x equals x minus 2 to the second power minus 3, what is the vertex and transformation from the parent function? Okay, so the parent function will always be at the vertex, and then 1 and 1, and then 2 and 4. This is your parent function, okay? So this is this is when f of x equals x squared. This is x squared. That's your parent function, okay? But here it's telling us a couple of things. First of all, if I look here, that -3 means that it was a vertical shift down 3 units. So from the parent function, from the vertex, I'm going to move down 3 units. 1, 2, 3. So we're right here. But then we had a horizontal change. And because it says -2, remember the formula says x minus h. So we just want to look at h. So h is just 2. That means it moved 2 units right. So from here, we're going to move 2 units to the right. 1, 2. So this is actually our vertex. Okay? Okay, so it's exactly the same. So you would have your next points, and then 2, 1, 2, 3, 4, right here. 1, 2, 1, 2, 3, 4. and this is your new parabola. So the vertex is at 2 and -3. And if you remember, this is h and this is k. H is right here, and this is k. Look at that, -3, -3. +2, +2. Okay, the rule was from the parent function, how did it change? Well, it moved to the right 2 units, and it moved down 3 units. So that was the transformation from the original, from your parent function. Let's look at another example. Okay, so here I want to go ahead and draw my parent function. So here's my point here, then 1 and 1, and 2 and 4. And I'm going to draw my parabola for my parent function. Oh my goodness. It's not the best, I'm sorry. Now let's find out what happened. What do you notice is going on here? There's a number, right? So at the beginning of the notes, we said that if you have a number here where a is, if the absolute value is greater than 1, that means your function is narrower than the parent function. Okay, so then what we're going to do is we're going to look at how did it get narrower, right? Now you could do a table so that you could find out the exact numbers. But I also want to talk about what happened. Was it a horizontal or vertical shift? Okay, here we have a horizontal shift. So because it says x minus 2, remember it's x minus h, we just want to look at h. That means it moved 2 units to the right. So from here, we're going to move 2 units to the right. 1, 2. So here's my vertex. It doesn't move up and down because there's no plus k here. So it stays here. Now, because it's a 2, it's going to be more narrow. So it actually, I'm just going to go ahead and show it to you. It moves, let's see, our next point is 1 and right here and right here. So if you were to do a table and check, this parabola should be more narrow than your parent function. I'm sorry that my drawing skills are not all that today. But you could use a graphing calculator. You could plug it in, and that way you can see how did it change from your parent function to your new function, to g of x. And you can use decimal. Okay, so the vertex, for this example, your vertex is right here. So we are at 2 and 0. And of course, again, this is h and this is k. As you can see, there's no k, so it's 0. And your h is only the number before the subtraction. Excuse me, after the subtraction. So from the parent function, we could see that the parabola, the transformation that it did was it moved to the right 2 units. So that's the transformation. It did not move up or down. It only moved to the right 2 units. There was also a change in the parabola size. So here it got narrower. So you could say, narrow graph compared to the parent function. Okay, so that's a wrap. I hope this helped. Feel free to drop any questions in the comments below, and have a good day.